Welcome to today's session on datasets. We'll be exploring how to handle different types of datasets effectively in your deep learning projects. Let's start with NumPy datasets. NumPy is essential for handling arrays of numbers, which can represent data such as images. You'll need some basic file I/O knowledge to work with these datasets, and we'll cover simple save and load operations today. For more complex operations, refer to the dedicated NumPy recitation. Moving on to Pandas datasets. Pandas is great for managing tabular data. It's important to note that while you won't typically receive your raw data in Pandas format, you will use it to manage and submit inference results during your assignments. The core of today's discussion is the PyTorch dataset class. This class is fundamental for handling more complex data needs in your homework and especially in projects. It allows you to read, organize, and pre-process data effectively. Understanding the structure and interaction of dataset and data loader classes in PyTorch is crucial. These classes work together to load training examples efficiently into your model during training. Before diving into the dataset class, it's vital to first understand your data. Load some examples, visualize them, and comprehend the shape and nature of the data. Also consider the real-world processes that generated this data. This step is crucial, but often overlooked. In defining a PyTorch dataset, there are three main functions that you will have to implement. First one, constructor function, which is init, that initializes the dataset object, and length function that returns the total number of samples in the dataset. And lastly, getItem function that retrieves a specific sample by index. Optionally, you might also need to define a collate function for more complex data batching needs, which we will cover in future sessions. When designing your dataset classes, consider several key factors. If your data fits entirely into memory, it's more efficient to load and pre-process all data in the constructor. This setup speeds up the retrieval of samples. However, if memory is limited, consider loading and processing data on the fly within the getItem function, though this may slow down data retrieval. You should also think about how you instantiate your dataset, whether directly from features and labels or from a directed path that requires loading files. Each approach has its benefits depending on the size and format of your data. For training and testing, it's prudent to define separate dataset classes. The test dataset class might differ since it generally doesn't have access to ground truth labels, affecting how you retrieve and handle data. To optimize your workflow, consider initially limiting the number of samples loaded for faster prototyping. Once you confirm your pipeline is functional, you can scale up to the full dataset. Now, let's look at a basic example of a dataset class. Here, we instantiate the class with feature and labels, define the length to return the dataset size, and use getItem to fetch data by index. We also discussed a more complex example using directory structure for cases where you deal with a larger dataset that did not fit into memory. I encourage you to explore these examples in the provided notebook. experiment with the templates and adjust them to your specific data needs. Finally, always validate your approach by testing different ways to index and retrieve data, ensuring that your dataset class functions as expected, just like this. So I want to encourage, to wrap up, I want to encourage to practice with this dataset class and walk through this example that is based on Kaggle data. That wraps up our session on datasets. Make sure to review the examples provided and understand the fundamental concepts as you prepare for more complex data handling tasks in your projects and homework. Thank you for your attention and see you in the next session.
Hello everyone, welcome to Recitation 0i, or the part 2 of Recitation 0i on datasets. My name is Peru, and in this recitation we'll basically be going over this notebook that introduces some of the data that you'll be working on for your homework 1 part 2. So in homework 1 part 2, you'll be doing a frame level speech classification task where you'll receive a dataset that consists of speech recordings that are encoded as something known as raw MEL spectrogram features, and you'll be receiving the frame level phoneme state. So MFCCs you can think of as basically being a form of feature engineering where the raw audio waveforms are converted into a set of spectral features in a way that better mimics our hearing, basically. So we will go more in depth in the write-up and later recitations on the topic of MFCCs, but you don't really have to know much about them beyond what will be covered in the write-up and later recitations to do this assignment. All right, so the dataset we'll be providing you with in homework 1 part 2 will have the following directory structure. You will have a train clean 100 folder with MFCC data and labels, which you'll be using for training. You will have a dev clean folder, also with MFCC data and label, that you'll be using for your model evaluation or as your validation step. And you'll have a directory called test clean, which will only have MFCCs and no labels, and will be grading your model's predictive performance on the samples in this dataset. Also, for each of these datasets, you'll be tasked with constructing a custom PyTorch dataset class. So to work through this notebook, we have provided you with a tiny subset of the homework 1 part 2 data. It should be in a zip file called Recitation 0i data. Should be linked somewhere in the video description. So essentially, you'll have to drag and drop it into the file tab here. As you can see, I have it right here. And then you can run this to unzip the dataset. I also have the dataset already unzipped here, and it has the MFCCs and about 15 of them and their corresponding transcripts or labels, right? So you can walk through this notebook. This notebook will walk you through loading a sample, printing their shape, printing its shape, printing the label shape. So as you can see, our MFCC data is basically organized as a 1825 by 28 two-dimensional array. Now our label is a vector of length 1827. Now there's 2 extra time steps in this label, and they're basically at the beginning and the end to mark what are called the start of sequence and end of sequence tokens. And as a pre-processing step in homework 1 part 2, you'll be tasked with removing them from all the samples. Right, so we can visualize one of the samples here. So here you can see the 64th sample and its corresponding label. You can also look at its shape. Now, an important thing to note here is that each sample just represents 25 milliseconds of speech, which might not be enough to train a model. So So because of that, you will be tasked with creating an adjustable context of k around the edges of each sample. So this is essentially done to create like a bigger feature vector that is more aware of the local information that is surrounding it. So so there's some examples walking you through how to apply a context window of 10 around each frame. So you can see what the shape now looks like. And then since you'll be primarily using a multi-layered perceptron for this assignment, the data needs to be flattened. So you can do that. And this is what the shape would look like after flattening. Also, visualizing the dataset can be very important. It can help you understand the underlying distribution of your data, spot anomalies, and even debug when you do things like transforms on images later during the semester. So I'll provide an example here about how you would go about plotting this MFCC frame. Note that the MFCC has been flipped and transposed to create a visualization that is more consistent with how MFCCs are traditionally viewed, where the x-axis is time, the y-axis is the MFCC feature, and the 0th MFCC is at the bottom. All right, so that is pretty much it for this recitation. Thank you so much for listening, guys. Do feel free to download the notebook and the accompanying dataset and work through some of the examples and maybe even take a stab at creating your own custom dataset with the tiny amount of data we've provided. Thank you.